Hello everyone. For this tutorial video I like to talk about how convection works, which is a lot more sophisticated than simple conduction, but can still be predicted somewhat using the general heat transfer equation derived earlier. In particular, convection is defined as the transfer of heat by the circulation of moving fluids, whether that be a liquid, like water in a pot, or gas, like the wind. The simplest type of convection, natural convection, comes from the fact that liquids and gases expand when they get hotter. So the warmer parts transfer heat upward, which you've probably already noticed if you have ever looked directly over a campfire. But there's also forced convection, where mechanical work causes the fluid to move, and so transfer heat in a very forced manner instead of by naturally rising, such as how coolant systems work in car engines. Owing to what we discussed earlier, and that the motion of fluids is often very chaotic. This means that there is no convenient, straightforward formula you can derive for convection, but there is an equation that works for all heat transfers, which we saw earlier, which was Q equals mc change in T. So we can use that to predict convection as well as conduction. For example, if we are given the dimensions of a house, and told that air gets replaced every 30 minutes, and we want to figure out the heat transfer to raise the air exactly 10 degrees Celsius, we would do this by noticing that although mass may not have been given explicitly because gas does not have a simple mass, we can calculate it as density times volume, and we are given every dimension for the volume. And we can simply look up the density of air, and then multiply those to get the mass as a result. So then we plug in 10 degrees Celsius for the change in temperature, as that is what we are asked to find, and then we plug in the specific heat capacity for air, which also must be looked up. And then we see, because this heat transfer over time, you have to divide this result by T, and you get a heat transfer rate of exactly 4.64 kilojoules per second, or kilowatts. It may be surprising that it uses this much energy, but since we know that air is a very poor conductor of heat, and the dimensions of the house are moderately large, this may help explain somewhat why this much energy is needed to heat it up by that amount. Now that we have described in detail how convection works, I can explain the final, most broadly seen type of heat transfer, which is radiation, such as in a microwave oven. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.